Did you know that double angle, power reduction, and half angle formulas are used extensively in calculus? I'll show you what all these formulas are and walk through some typical example problems where all these formulas are used. Welcome to Understand the Math. We've created free guided notes that you can use as you watch this video and placed a link to them in the video description below. There's space in the notes for you to highlight the important concepts and to fill out the answers to the examples that we're going to do. I've broken this video down into 3 sections since we're going to be looking at 3 different types of formulas and examples. We'll start with a quick overview of double angle formulas and then dive into an example problem. There's a double angle formula for sine, cosine, and tangent. Notice that there are 3 forms for the formula for cosine of 2 theta. These formulas can be thought of as special cases of some formulas. I've included the derivation of these formulas here if you want to see the details. Let's now walk through an example problem that requires the use of one of these double angle formulas. We're asked to find sine 2x if sine x is minus 5 over 13 and x is located in quadrant 3. We'll begin by writing down our double angle formula for sine of 2x. We have sine 2x is equal to 2 sine x cosine x. We're given that sine x is minus 5 over 13, so what we need to do is we need to find cosine x. To find cosine x, let's draw a unit circle and place our angle x in quadrant 3. Sine x is equal to minus 5 over 13, so our opposite side is equal to 5, and our hypotenuse is 13. Cosine x is equal to the adjacent side divided by the hypotenuse, so we need to find the adjacent side. From the Pythagorean theorem, we know that the adjacent side squared plus 5 squared is equal to 13 squared. This gives us the adjacent side squared plus 25 is equal to 169. If we subtract the 25 from both sides, we get that the adjacent side squared is equal to 144. Taking the square root, that tells us that the adjacent side is equal to 12. Cosine is also negative in quadrant 3, so we get that cosine x is equal to minus 12 over 13. We now have that sine 2x is equal to 2. We'll plug in our sine x, which is minus 5 over 13. And now we can plug in our cosine x, which is minus 12 over 13. When we multiply all these numbers out, we get that it's equal to 120 divided by 169. And that's our final answer. Let's now look at power reduction formulas and walk through an example problem. All of the power reduction formulas can be derived for one single formula, and that formula is our double angle formula for cosine. I've included the derivations here if you want to see all the details. There's a power reduction formula for sine squared theta, cosine squared theta, and tangent squared theta. The example that we're going to look at is to rewrite sine to the 4th x in terms of the first power of cosine. This type of problem comes up a lot in calculus. We need to first recognize that sine to the 4th x can be written as sine squared x squared. We can then use one of the power reduction formulas and plug in for sine squared x. This is equal to 1 minus cosine 2x divided by 2, and that becomes squared. To make things easier, we'll go ahead and bring out the 2 squared, which is 1/4. And then we have 1 minus cosine 2x quantity squared. This is equal to 1/4 times 1 minus 2 cosine 2x plus cosine squared of 2x. We'll now use a power reduction formula for cosine squared. We have cosine squared x is equal to 1 plus cosine 2x divided by 2. That tells us that cosine squared of 2x is equal to 1 plus cosine 4x, because we had to double the angle, all divided by 2. Let's now plug this in. This is equal to 1/4 times 1 minus 2 cosine 2x plus what we just calculated in purple. We have a 1/2 plus cosine 4x all divided by 2. We can combine our constants, multiply them by 1/4. So we have 1 plus 1/2 is 3/2 times 4 is 3/8 minus 1/2 cosine 2x plus 1/8 cosine 4x. And that's our final answer. The last set of formulas that we'll look at is half-angle formulas. We'll then walk through an example where we'll use this formula to find the exact value of a trigonometric function. Half-angle formulas are derived from power reduction formulas. Just like I did for the other formulas, I've included the derivations here if you want to see the details. There's a half-angle formula for sine, cosine, and tangent. Notice that there are 3 forms for the tangent formula. The plus or minus in all 3 formulas depends on the quadrant of theta divided by 2, which makes these formulas a little bit more complicated. Let's now do an example so I can show you how to implement these formulas and also how to choose the correct sign. We'll find the exact value of cosine of 112.5 degrees. The key to doing this problem is to think of 112.5 degrees as half of an angle, which we'll call theta divided by 2. So we have theta divided by 2 is equal to 112.5 degrees. If we multiply by 2, we get that theta is equal to 225 degrees. We'll use the half-angle formula cosine of theta divided by 2 is equal to plus or minus the square root of 1 plus cosine theta divided by 2. Let's now plug in for theta divided by 2 and theta. We get cosine of 112.5 degrees is equal to plus or minus the square root of 1 plus the cosine of 225 degrees divided by 2. 225 degrees is located in quadrant 3. To find the cosine of 225 degrees, we need to look at the reference angle. Our reference angle, which we'll call theta sub r, is going to be equal to theta minus 180 degrees. So this is equal to 225 degrees minus 180 degrees, and we get 45 degrees. Cosine is also negative in quadrant 3, so cosine of 225 degrees is equal to minus cosine 45 degrees, and this is equal to minus root 2 divided by 2. Before we plug that value in, we need to choose the sign for our angle. 112.5 degrees is in quadrant 2, and cosine is negative in that quadrant, so we need to pick the minus square root. This gives us cosine 112.5 degrees is equal to minus the square root of 1 minus root 2 over 2, plugging in cosine of 225 degrees, all divided by 2. Let's rewrite this in a different way so that we can see our fractions easier. Let's write this as 1/2 minus root 2 divided by 4. If we get a common denominator of 4, this becomes 2 minus root 2. We can then pull out the 4 and take the square root of it, so our answer becomes minus 1/2 times the square root of 2 minus the square root of 2. I hope that you now feel more comfortable using these 3 different types of formulas. I think you'll be really surprised how much you use these formulas in future problems. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.